Okay. Real quick, just walk through the material that you might see on the test. All right, so the test is through 137. Yeah, I guess that's in there. That's below 137. Actually, 136. Sorry, I don't want piecewise on there, so it's going to be through 136. Piecewise is still a work in progress. So let's talk about that. 136 is fundamental theorem part 2 with chain. So for example, if I say what's the derivative with respect to x of 3x squared to 2 of arc sine of u cubed u, you would say the answer is negative. I like that. What else? Arc sine of 27x to the 6 times 6x per chain rule, yeah? Now, if you don't know where people are getting that, then you best review that or someone can get help. Or you can just shrug your shoulders and say, I don't get it, oh well. Okay, 135 is absolute convergence. Absolute convergence is, generally speaking, when what happens? When an alternating series converges when you take the absolute value of the terms, yeah? In other words, if it converges without. So you typically take the absolute value of the terms to get a positive term series and do the convergence on that. What does the conclusion maybe look like if we're maybe concluding absolute convergence? What might we say? The positive term series converges. Therefore, the alternating series converges absolutely, eh? Okay. I guess now's as good a time as any. Let's talk about testing for convergence. That's kind of a big idea of calculus 2. What's the first thing you check? Nth term test. Do the terms go to 0? It would be a darn shame on a test where the teacher is constantly making the test way too long if you then took a series that failed the nth term test and did all these tests on it when you could have just said the terms don't go to 0 at divergence, period. Yeah? That would be a major time loser. Yeah? So check that first. Give me another thing you might do to check for convergence. Telescoping. Okay, let's globally call that known series. One is telescoping. What's another? Geometric and p-series. Let's pause for a little side practice there. Say I had geometric was something like 2 minus x is less than to the n converges. What do you know about, actually let's go 2 plus x converges. No, I like 2 minus x. Let's make it difficult. Okay, what would you know about x? Well, let's start with 2 minus x. What would you know? Okay, when does geometric converge? Or when r is between -1 and 1, yeah? Okay, so subtract 2, -3 is less than -x is less than -1, yeah? And so x is, now this is actually about to be bad math, what I'm about to write there. Okay? Oh, actually, it's not. It's fine, yeah? So x is between 3 and 1. That makes sense because if it was 1, then that would just be the cusp of fractions. So greater than 1 would be less than, or greater than negative 1, so that seems right. You with me?
Yep.
All right. What about this bad boy? What if you had negative 1 to the n, square root of n, and down here you had n to the 2p plus 2 all squared. And I said this converges absolutely. And I asked you to find p. How would you do it? All right, so you should strive to make it n to the blank. You should get everything down in the denominator as an exponent. Everything. You with me? Second, your focus is on dominant terms, so this too means nothing. I can tell. You follow? All right, so here we go. What is the overall power of n? N to the 4p squared. So tell me this, is this x to the 9th? Yeah, no, you're not squaring that exponent. That's not an exponent rule. You're making something up right there. So try again. Is this p squared? No. 2p to the second is what? 4p. You multiply exponents. Okay, so x to the 4p minus a half. All right, cool. Now let's start with the condition. 4p minus a half must be greater than 1, so 4p must be greater than 3/2, so p must be greater than 3/8. You follow? All right, so the process is get everything, ignore little terms, focus on dominant terms, get everything to the denominator, and then do the condition. All right, back to the convergence process. All right, so nth term test, check that first. Known series, check that next. What else could you do? In any order, I don't care what order. What other tests are there? Ratio test. The ratio test, what is the, when do you use it? When you use factorials and exponents, okay? But not geometric maybe, or combinations of. How does it work? What do you do? The n plus 1th term compared to the nth term. Make sure that you don't rush this. I will count off if you don't show me this or the terms themselves over each other. If you rush into, hey, I'm putting this in and doing factorials and putting it side by side, that's too much. Sorry. I have a point built in for it. Do you communicate what the heck you did? So, for example, if I said this, and your first step is this, oh my God, Rick is so, he makes his test so long, I gotta go here. Too much, sorry, you just lost a point. I have no idea what you're doing. It's not clear you're doing a ratio test. You're going too fast. All right, is that clear? I need to see either this and then go to that, fine, or this. One of those, I've got to see it. One of them I've got to see it. You with me? Otherwise, it's not clear what you're doing. Okay, what is the test? What converges of what happens?
Less than 1.
Less than 1. So you would find the limit. You wouldn't just say it's less than 1. You actually communicate, I know the limit. And then you'd say it's less than 1, and then you conclude converges. The end component to this should have 1, 2, 3 parts. What's the limit? What's the test? And the conclusion, does it converge or diverge? Understood? Okay. If the limit is 1, what does that mean? Inconclusive. Inconclusive means you stop and you broke math, yeah? No. What does it mean? You chose badly. You go and do another test. You don't say inconclusive, that's my answer. That's not an answer. That's the same as you didn't do the problem. You came to no conclusion. You have to do more. Okay, so I have people on the homework that say inconclusive, circle, not okay, not okay. Okay? 4. What else? What other tests you got there? Root test, okay. The root test. You guys and root test are just in love right there. That's you guys. That's you. I have no idea. I don't know. I must have taught the freaking heck out of that thing because it was one of the most worthless tests and used it all the time. But I gotta say, you do it pretty well. But man, whoa, baby. It is very much the same kind of. There's a lot of overlap between that and the ratio test. The test obviously is different. You're taking through to the term formula and finding the limit, how it compares to 1 again, and the conclusion. And same goes with inconclusive, converging and diverging as it compares to 1. What else? 5? What's another test? Direct comparison test. You would say that falls in the family of comparison tests. DCT and LCT are in the same family. They compare to. You would use them when something's close to a known but uglier. For example, if you had 5n squared plus 7 pi e over 3n to the 5th plus 7 arctangent of whatever 2. I don't care how ugly it gets. All I care is about the dominant term. So I would compare to one of 2 things. What's one thing you might compare to? 1 over n cubed. You can compare to 1 over n cubed. What else might you do? 5 over 3n cubed. They're both the same. The power needs to be right. Obviously, the n cubed needs to be the start of the show. But whether you do the coefficients or not is up to you. The conclusion will come out the same. What will be different? The limit. All right, so in that quiz I handed back to you, maybe I didn't hand it back to you because Shannon didn't actually take hers out of the practice back. Here was over here. Shannon's the worst. All right, here you go. Now you can just get it with it. But in this little quiz that you took last week, some of you did the ratio test correctly or did the test correctly, but you found limit comparison test correctly, but you found the limit wrong. I care about that. This is calculus class. I think you should be able to find the limit right. Go figure. So I do grade for the limit. It needs to be accurate. The good news is it won't affect your conclusion. You won't be out on the conclusion unless you really botch the limit. Limit comparison test is what I want to see probably tomorrow. It's the most useful. Direct comparison test is useful in a couple cases specifically, like when you have natural log and you use it compared to the square root. That's a direct comparison test case. Also, when you have sine or cosine, you might use that idea. That also goes well with direct comparison test. Otherwise, I think your first thought should be limit comparison test. Are you with me? Am I going too fast or is this okay? Okay. All right. What else? I'm missing a test, at least one. Integral test. What are the conditions for the integral test? Positive, decreasing end. Continuous, obviously, it always ends up comparing to an improper integral, so you have to have skill there. And logs often happen, and you get that. I think that's all on convergence tests. Back to my outline. 134 is polar with derivatives. You can't even really get started if you don't know how to find x and y in polar. So how do you find x? R cosine theta. And obviously then usually you put the equation in for r, and y is r sine theta, and again you put the equation in for r. That could be used to find a point. How do you find a slope? dy dx, which is dy d theta over dx d theta. So you would first find these and then take derivatives. And you should be able to do it with or without a calculator. Yes? You do not have to do R plane. Good question. I forgot about that. Yes?
So if we can use our calculator, can we just write like the
Yeah. So that's a good question. I would expect this much and nothing else. I do think this communicates your process, and that's important. No, I take it back. I misspoke. I would want X and Y, how you know, communicate that you know how to find X and Y, one of those two, and then that. You're right, that's important. I missed this one. Okay. Also in that chapter was interpreting R prime. So remember, R is equivalent to distance from the origin. So when they say when is the distance from the origin increasing, you need to interpret that as R is increasing and look into R prime. But when is the distance from the origin increasing in polar? R and dr d theta are same sign, yeah? So it's either a positive R and it's getting bigger because dr d theta is positive, or it's a negative R and it's getting smaller because both are negative. You follow? I think that's all there. 133 is Euler. So this is where I pause and apologize. I think there was one on last night, so we're pretty at the 8 iteration.
Plus 4, 12.
12?
Yes,
It was 8. It was 8 times. 1 4 and then 4 and then 8.
I totally apologize. That was ridiculous. I love that there are people in this class that say, or willing to say or do. I know I would say screw it. But that's just me. I wasn't as good a student as you. That said, I will never do that on a test, and I'll try and remember on the homework to never make that happen. It would be at most 3 steps, probably less. Every AP I've seen on free response was 2, and I have seen one multiple choice that was 3. But my emphasis is quality work. Now, part of that is my fault. If I'm giving you a ton of steps in the homework and I forgot to change it, then it's hard to do formula substitute evaluate for 8 iterations. That's ridiculous. Okay, but tomorrow I expect quality work. And the rubric I use will be for every iteration you show the formula y initial is, or y1 is y initial plus dy dx at x initial y initial delta x, and then you substitute numbers in, and then you evaluate. My rubric looks something like this. If they don't have this, stop reading. I will not look at your numbers. I will not look at your answer. I will just say my mistakes and move on. I am not going to interpret your calculations. I don't care what your numbers are. I care what your process is. Okay? And you better show that, or don't waste your time even doing it properly. All right? Those are very common multiple choice and very common free response. It's possible it's one or both. 132, we're starting to get into pretty old territory here. 132 is limit comparison test, which we've talked about. What does the conclusion to limit comparison test look like?
0 is less than L equals some.
Because 0 is less than, because the limit is between 0 and infinity, and the given thing, whatever converges or diverges, the given series must also converge or diverge, whatever. You with me? Okay. And explain why the comparison series converges. 131 is improper integrals. Please, I beg you, differentiate between this and this. Oops. First one, Calc 1 or Calc 2? Calc 1. Is there any issue with improper integrals there? No, the vertical asymptote's -1. I'm not interested. I don't care. Would that require any limits in the first one? No. Second one, how many limits would you need? 2. What about this? How many limits would you need? 1, this. How many? 3. Okay, 0 to 1, 1 to some number, 2, and 2 to 3 numbers. Yeah? Gary! Come on, Gary. Freaking sophomores, can you believe it? All right. What about when you have separate limits with separate variables and you get results like that, can those be combined? Is there any way around the indeterminate, or it's just indeterminate? It's just indeterminate. All right, I think at that point, that's pretty much it. The AP that you did last Friday, A, B, multiple choice, and free response, they're going around. I will use some of those on the test tomorrow. So if you didn't go through your answers well, then I would go through your mistakes well and make sure you, if you didn't get those graded or whatever happened, I would make sure that you look at those well. Yes? That's a really good question. Let me answer that by looking at it. May I look at this? So, yeah, I'm all for killing two birds with one stone. So on tonight's homework, these are problems that might help you prepare for the test. 1, 2. The fourth one. Oh, shoot, there's 2 fourths. Oh, you get there. Let's see. I wish I would have numbered these down. I didn't care when it was your problem, but now it's my problem. So, 1. That's conditional convergence. Never mind. That's help. So I'm not answering the question very well. Let's go with you see the fourth problem down, the polar one with multiple choices? Yeah. Do that one for sure for test prep. And then 4C. 4C is also a good one. That's an Euler problem.
Sorry now.
And I think that's it. Okay? Maybe actually let me also look at that. What are the book problems on the back? What numbers?
11.
So on the back side, the book problems, 11 is a good one. 11 will help you prepare. 13 is good. 14 is good. 18. Okay. All right. That's a good question. You're so smart. Test is going to go great, right? I will be, if there's something you stink at or you need more practice on, you want to talk over, I'll accept that, or I'll help you with making more practice. Coming back to school or coming before school tomorrow. Okay?
Sure, think I can see.
Can you
It's
say
the
what
AP, it's like the AP review, like I have to study. Yeah, but I have to keep the study. Yeah. So.
I guess it's going to be late no matter what, so might as well, yes.
Is subtracting with decimals the same as
Oh,
adding with them?
wrong division tomorrow. Subtracting with decimals?
Yes. So do you still line up like we did with the addition
Yes,
yesterday?
that has not changed. You still line up the decimal point when you subtract the question.
Okay.
Yes. I forgot to put division. Yeah, I need to add the division problem.
Which one is the we should have had a long
Maybe
division
we'll
practice
start with that. You don't want to. It's going to hurt your confidence starting with division. Maybe the problem is you can't divide confidence. Well, maybe you should do something about that. All right, here we go. How did we get through the Janet thing or no? Did we get through Janet's driveway? We're on C. Cool. On C, I think we talked about the snow Janet's removed is 0 from 0 to 6. And then it's not 125 t because t represents time since midnight. It's 125 t minus 6 for the second branch, yes? And I think then we start to get into the third branch. So remember that the amount of snow is continuous. It's how much she does in the first 6 hours, smoothly transitions to 6 to 7, smoothly transitions to 7 to 8, or 7 to 9. So we need it to be continuous. So I need to, before I go to the third branch, I need to figure out where she left off the second branch. How much did she shovel from time 6 to time 7? 125 cubic feet. So our starting point is 125, and now we're going to add in more snow shoveled. How do I find out or express how much more snow shoveled afterward? 108 times the time since 7. You follow? All right. So that, I think that makes sense. At 7, it would be 125. At 8, it would be 125 and 108. And at 9, it would be 125 plus 108 twice. So it feels like it's working in terms of common sense. You follow? All right. C, D, D. How many cubic feet of snow in the driveway? There are a couple ways to do this. I would very commonly see this. Is that okay? That's enter snow minus leave snow. Is that okay that way? That's not okay. That's bad calculus. What's wrong with that? G is not a constant function. It's not clear what you're using for G at different times. So anytime you have a piecewise, something like this is not okay. You have to do better. So I could do 0 to 6 of f at t, and then 6 to 7 of f minus 125, and then 7 to 9 of f minus 108. That's one way to do it. Some people said, you know what, I just separated them all together, and I said how much snowfall, remove how much snow shoveled, and people then just did something like this. Is that okay? Is that, oops, that should be 125. Does that look okay? Yeah, that's fine. Could you also just say, you know what, I found out how much snow fell, and I already know how to find how much snow was shoveled. It's this guy. And they just said use snow shoveled at 9 to find out how much snow shoveled at 9. So there's a lot of ways to find it, but your answer, my answer was 26.335 cubic feet. Do you agree? Oui or no? Oui. All right. This bad boy. I hope you got the P must be greater than 2. And then P must be less than 1. And then P must be greater than 7/3. Would you like to talk about any of those? Sure. So I don't really care. The absolute convergence is going to wash that out. So I'm just focusing on the ends. My process is to get everything down in the denominator and make it a nice clean n to this power. So if I do that, the bottom part is 3p minus 4, but over 2 because it's square rooted, yeah? And when I bring down this guy, it would be minus a half. After that, I take the total power and use the condition that it has to be greater than 1 to converge. And then I solve from there. Okay? On 3A, what test did you use? Ratio test. And did you get that it was indeed absolute convergent? Good. It says prove the series is absolutely convergent, so I hope they do converge. Unfortunately, the next one, what's the first thing you should check? Do the terms go to zero, do they? No, tricked you. It's not actually absolutely convergent. Not that it was intentional, actually, but the terms go to positive or negative infinity, or does not exist, not equal to zero, so this diverges. If it diverges, it can't converge absolutely, you'll find. All right, 10. 10, how does something like arc sine of 3e to the x minus 1 times e to the x grab you? Oui, oui? Yeah. Oui, oui. Okay, backside, backside. The only ones that look anything close to logistic are b and e, yay? Okay, that's exponential growth. This is linear, that's parabolic. That's Newton's law of cooling. All right, so which is it? B or E? E, it has to be dependent variable in there, which is y. It is E. All righty. What's this?
Formula for that?
Oh, yeah, sorry. It is, this isn't on the test, by the way. I just don't want you to forget it. dy dt is ky L minus y, where the rate at which the population grows depends on how many zombies there are and how many zombies there are, or how many left to infect, kind of thing. Yeah? Okay. Excuse me. A, I assume that it went okay because you have implicit skills, but I will mention this. When the question, words like this on the AP test, when they say, show the answer is, they're giving you the answer because they don't want you to be out for parts B, C, and D. That said, to earn the credit, it's not enough to find the derivative like you normally would, skipping steps all over and being able to say, hey, look, I got the right answer. That's not to your credit. The answer's there. When it says show, you have to go very slow because you don't get to say, look, I got the right answer. They're giving you the answer. It's, I mean, good algebra, factoring, slow, slow, slow. Okay? Be careful. Second derivative, I simplified mine not at all. And so here's my second derivative, totally unsimplified. I have 3 times y plus 1 times negative 4 minus negative 4x times 3 times the derivative, which I substituted in, negative 4x over 3 times y plus 1 over the square of what's below 3 squared y plus 1 squared. Okay? So as long as yours is equivalent, you should be good to go. Are we good there? Bene, bene. Okay. If I had another couple days, we would do polar forms of conics. All conics are of the form, I think it's something like this. Sine or cosine. Parabolas, ellipses, circles. Not so much circles, but they all kind of different forms of that equation in polar, depending on where the A, B, and C lay. It's useful in astronomy. But at any rate, you got your equation like this, and as theta increases, on what interval is the distance between the origin and the point increasing? What do you read that as? Distance between the origin and the point increasing means when is? Yeah, distances, think r is increasing, and that is, so when, actually absolute value of r. So r and r prime, same sign, yeah? Now, I don't know about you, but I started by looking at r. What about the sign of r? What is it? Okay, what's the least sign can be? So what's the least 2 plus sign can be? Can the denominator be positive or negative? Nope, always positive. So what's our sign? Always positive. R is always positive. I did not waste my time getting into that. And so I just said, when is R prime positive? So, in finding R prime, did you do quotient rule, or did you do a rewrite and call this a times 2 plus sine to the negative first and chain? What did you do? Rewrite. All right, so what is R prime? Negative 3 R plus, or sorry, 2 plus sine to the negative 2 times cosine, or negative 3 cosine over 2 plus sine squared. We've already established that the denominator is always positive, so in terms of figuring out where zeros are and then sign testing, the zeros, where are they? Did you say pi over 2 and 3 pi over 2? Oh, you should. Okay. The bottom can't be 0, cosine is 0, pi over 2 and 3 pi over 2. And then the question is, what about the signs? R prime is negative, positive, negative. So I said R, the distance is increasing on pi over 2 and 3 pi over 2. Because R and R prime are both positive. Follow? Okay, and last but not least, if we throw, if we throw a circle in here and shade, this is the shade area I interpreted as they wanted, yeah? Okay, so where are the intersection points? 7 pi over 6 and 11 pi over 6. Did that go okay finding those? Okay. Did you use symmetry or not? You did. Okay. So if you use symmetry, then you started where? 3 pi over 2. Okay. So you started at 3 pi over 2 and went to 11 pi over 6. And what is your integrand? Outer squared. Is it outer minus inner all squared, or is it outer squared minus inner squared? Outer squared minus inner squared. What's outer? Is it the funky curve or the 2? Funky curve. And the inner is 2. How'd that go? Studying? Bene, bene, molto bene. Okay. For this bad boy, which ones did you rule out right away by sketch? The positive ones, so no chance. Negative slope, then the question is then you start getting in, is your picture any good? So that's kind of tenuous there. I wasn't very confident in my picture, so it was actually B. It was more flat than my picture. I got B. Do you agree? Okay, 7. I have the max distance is 3.288. Do you agree with that? Okay. The other class definitely did not follow that. Any questions on that? Are we good? Okay. So and last but not least, I have negative 15 fourths. For that. Obviously lots of work. All right. Anything you'd like to talk over before we move on? This last one? Sure. So, in terms of work I would expect to see, I would see something like x initial is 1, y initial is negative 3. Then you roll on, I have clear in my head, delta x. Delta x is to go by a half. Sometimes they tell you, like in this problem, sometimes they don't. Do pay attention to signs. Remember, once in a while you go down, save up. But x1 is a half, yes? y1, formula, y initial plus dy dx, add x initial, y initial, delta x, substitute. The initial y is negative 3 plus, and I get into the derivative at the previous point. So that's 2 minus 3. And the delta x is a half. So I have negative 3 minus 0.5, so I have negative 3.5 there. I actually, very rarely do I use decimals, I use fractions, it's way easier to do. So negative 7/2 is what I really have. You follow? And then on we go to x2, which is going to take me to, I screwed this up, sorry. I started at 1 and went up 1/2, so x1 is 1.5, yeah? Sorry about that. x2, going from 1.5 up another half takes me to x2, which is 2. y2 is y1 plus the derivative at the previous point. Formula. Substitute in for y1 goes my leftover remaining y, negative 7/2, so previous y. dy dx is 2 times the previous x, so 2 times 1.5 is 3, plus y was my previous y, so minus 3.5, times the delta x of 1/2, so I got negative 7/2 times negative 1/2 times 1/2, negative 7/2 minus 4 is negative 14/4 minus 1/4. That's right. Does that make sense? Okay. Sure. Yes. So is this relative? Greatest distance to me reads absolute max. I started by saying absolute max R, but then it doesn't really, I don't really care about the sign, so it could be actually biggest positive or negative value, right? Because if I had something that backed me up 7 from the origin, and another one where I went forward 5 from the origin, what's the max distance, 7 or 5? 7 is the greatest distance. So it's actually absolute max of R without the sign in it. Don't worry about that though. That doesn't come in until later. It's not like that's going to affect your derivatives. So I know that must be at an endpoint or a critical number, yeah? The endpoints are obvious. X equals 0 and 3/2. But the critical numbers, R prime, or geography theta if you like, is negative theta sine theta plus cosine theta, yeah? I need to find, like all critical numbers, places in the domain where that's 0 and defined. I thought about trying to do that by hand, but it was a no-go, so I picked up my calculator. Now in my calculator, you're not going to graph this in polar because all the functions of intersections and zeros, they're inactive in polar. So you're actually going to graph in rectangular y equals negative x sine of x plus cosine of x, and set my window to 0 to 3/2 so I don't look for some point that's not applicable. And then I found the zeros. This happens, or the critical numbers are at theta of, the places where that went 0 were 0.8603 and 3.425. You follow? And then as far as evaluating what has the greatest distance from the origin, I found out what is R at each of those. R at 0 is 0. Not very interesting. R at 3/2 is also 0. Not very interesting. R at 0.8603 was a forward distance of 0.561, and R at 3.425 was a negative 3.288. So to answer the question, when is the distance? Does it say what is the greatest distance or when is the greatest distance? It says find the greatest distance. Well, this is the one that's furthest from the origin, so that was my choice. Okay. All right. Anything else on this paper? Make sure I get it by the end of the day. This bad boy, as much as we can, but we'll still probably be turning it in so I can check that you're giving an effort. So here we go. First one, did you graph? First, sorry, I left off a 1 in the numerator, my bad. I assume you figured it out, Lee. Okay, do you remember your solution curves through 250? Did you look something like this? Yes? And through 1500 is logistic decay, so like that. It does not have an inflection point. So far, so good? Cool. All right. If B is 250, so that case, what's the largest rate of increase in the number of frogs? When largest rate of increase means when is the rate of change greatest, yeah? And doesn't that mean dy dt is greatest, yeah? And when is that happen? When, just generally speaking, for logistic, that's when the population is half the carrying capacity. What is the carrying capacity here? 1010, so that is 505. So that's when y is at 505. Right here is the steepest growth rate. That looks right. But it doesn't say, what's the population then. It says, what is the greatest rate of increase? So now what do I got to do? Plug it into dy dt, yeah? dy dt at a y of 505. I found that, and I had something like 102.01. Yeah, what are the units on that? Frogs per week. Okay. Now, 750 as a starting point is already above the half carrying capacity. So it misses that fastest growth rate. So when will the fastest growth rate be for a curve like that? Right away when it's at 750, that's when it's going to grow the fastest. So you would say something like 750 is above half the carrying capacity, so the max is at y is 750. And when I did that, dy dt was 678 frogs per week. You agree? Cool. F4 here, I have a mistake in my work. It was something like 280. Does that sound right? 290, what is it? Maybe. 288.535. And that was Euler 2 steps, so hopefully you did that well. Okay. What about over or underestimate? Under, why? The curve is concave up there. Euler, remember, is like tangents, but repeated tangents. So it behaves the same way as tangents. If the curve is concave up, the tangent line falls below the curve, and it'll be an underestimate. I know we haven't gone through the rest, but I want this by the end of the day. I will say I just want to hold you accountable for not just copying everything I do. I want to see that you're just trying these on your own. That's all I want to see is that you're trying. Okay? So get it to me by the end of the day, please. Have a good day.
That one? So if it's depending on the population that you have, if you want to